Imagine a vast symphony played by a massive orchestra, with an uncountable number of stars, planets, and moons all joining together in perfect harmony. Yet, within this grand cosmic performance, there is one area that has perplexed scientists for years: exoplanets. Exoplanets are planets located beyond our solar system, hidden somewhere deep within the Milky Way galaxy. You might be amazed to learn that some of these exoplanets share remarkable similarities with Earth, creating an intriguing possibility. This discovery opens the door for a twist, like something out of a captivating science fiction saga. Researchers, using the James Webb Space Telescope, made an unexpected finding from Proxima b, uncovering a peculiar signal so complex and structured that it sparked widespread debates across scientific circles and social media. Dubbed a potential text signature, the signal was an electromagnetic emission so sophisticated that it suggested the possibility of an advanced civilization residing in the area. Humanity's collective excitement reached a peak as this discovery threatened to revolutionize how we perceive our existence. Could this be the long-awaited proof that we are not alone in the universe? However, just as mysteriously as it appeared, the signal faded away, leaving behind a haunting silence and a web of unanswered questions and emerging theories. Was this merely a fleeting cosmic event, a random alignment of celestial bodies, or could it be a deliberate message, an indication of a distant, unknown presence? This singular event cast a shadow over Proxima b, prompting a flood of speculation and curiosity. Was this an anomaly, or is there a much deeper story waiting to unfold? But the cosmic story doesn't end here. The ink on this narrative is still fresh, and new chapters are still being written. This time, it's not just the usual scientists but renowned Harvard experts who are leading a shift in the way we approach the search for alien life. Their research is pushing beyond simply analyzing the signals and anomalies we've already detected. They've expanded the search by turning the James Webb Space Telescope into an enormous night vision device, designed to detect artificial light sources across both dark and illuminated regions of distant worlds. One exciting possibility under investigation involves detecting Earth-like urban environments glowing like radiant cities in the vast darkness of space, shining across the endless ocean of the cosmos. As we continue to unravel the mysteries of the universe, the search for extraterrestrial life is becoming more profound than ever. This effort transcends the intrigue surrounding Proxima b and delves deep into the far reaches of space, fueled not just by new technologies but by an insatiable curiosity about our role in the universe. Ongoing advancements in cosmology and space exploration have already identified numerous exoplanets that could harbor life. Tools like the James Webb Space Telescope, JWST, and ground-based observatories are significantly enhancing our ability to detect and study these distant planets. One particularly exciting field of research is the search for biosignatures, signs of life. These could include atmospheric gases like methane or carbon dioxide, which, under certain conditions, suggest biological processes. The JWST goes far beyond just detection. With its advanced instruments, it is capable of measuring an exoplanet's atmosphere precisely. By studying the starlight filtering through an exoplanet's atmosphere, scientists can identify chemical markers that indicate the presence of life. For example, finding water vapor alongside oxygen or ozone could point to conditions that support life. Another promising avenue of investigation is examining the environments of these far-off planets. In addition to biosignatures, the concept of technosignatures, traces of advanced civilizations detectable through their technologies or artificial structures, has gained momentum. These may appear as megastructures, such as Dyson spheres designed to capture the energy of stars, or strange radio signals. As our observational techniques improve, the search for technosignatures may reveal signs of extraterrestrial intelligence. Beyond technology, the search for life also hinges on international cooperation. Collaborative efforts between space agencies, research institutions, and private enterprises are crucial in advancing our ability to explore space. Missions to Mars and other celestial bodies, for instance, rely on pooling global resources and expertise to achieve shared goals. Public engagement and education are also vital, sparking interest in space science and encouraging future generations to pursue careers in STEM fields. Technological advancements are key to deepening our understanding of the universe. Improvements in telescope design, data processing, and computational modeling have enhanced our ability to study faraway exoplanets. New space telescopes, like the Extremely Large Telescope, ELT, and the Habitable Exoplanet Observatory, HABEX, will soon offer even greater observational capabilities, providing more detailed insights into the habitability of distant worlds. Each new discovery brings fresh questions and opens new areas for exploration. The search for extraterrestrial life isn't just about discovering alien civilizations, it's about understanding the origins and diversity of life across the cosmos. This pursuit challenges our worldview and helps us learn more about what it means to be alive. In conclusion, the exploration of exoplanets and the search for alien life is a dynamic and evolving field. Each advancement brings us closer to answering some of humanity's deepest questions. As we push forward in our exploration of the universe, the possibilities of discovering new forms of life and understanding our place in the cosmos seem limitless and tantalizingly close. Proxima b, a potential twin of Earth just 4.2 light-years away, stands as one of the most fascinating puzzles of our time. The James Webb Space Telescope is transforming how we search for extraterrestrial life, opening up new understandings of these cosmic mysteries. Picture a moment when your thoughts drift across the immense vastness of the Milky Way, which is home to a mind-boggling number of exoplanets, more than a quadrillion, or a 1 followed by 15 zeros. To visualize this, imagine that each of these planets was the size of a grain of sand. This would be enough to fill the Grand Canyon, and create another version of it, stretching across an immense distance. What's particularly astonishing is that about 20% of these planets have been identified as Earth-like in terms of geography and environmental conditions. This means that there's a 1 in 5 chance of finding an Earth-like twin in the universe. The story doesn't stop here. Alongside these exoplanets, there may be another quadrillion moons, rocky satellites orbiting their parent planets, locked in gravitational motion. The universe offers an endless array of possibilities for discovering worlds that could support life or may one day be capable of doing so. Now that we understand the magnitude of this vast expanse, let's turn our attention to the true key player, the James Webb Space Telescope. This extraordinary instrument, with its impressive focal length and adjustable lenses, surpasses even the most advanced optical technology. The enigma of Proxima b. Despite its proximity, Proxima b remains shrouded in mystery. Astronomers believe it orbits within the habitable zone of its parent star, Proxima Centauri, a small but active red dwarf. This habitable zone, often called the Goldilocks zone, is the region around a star where conditions might allow liquid water to exist. Yet, there's a catch. Proxima Centauri is a highly volatile star, frequently emitting intense solar flares that could strip away a planet's atmosphere over time. This raises a pressing question: could Proxima b still sustain an atmosphere thick enough to protect it from harmful radiation? The James Webb Space Telescope is helping scientists answer this by studying the planet's atmospheric composition through transit spectroscopy. By analyzing how Proxima b's star's light filters through any potential atmosphere, scientists can determine whether crucial elements, like oxygen, nitrogen, or carbon dioxide, are present. If a dense atmosphere still exists, it could act as a shield, protecting liquid water on the surface. Another intriguing question is whether Proxima b is tidally locked. If so, one side of the planet would be in perpetual daylight while the other remains in eternal darkness. This could create extreme temperature differences, making habitability even more complex. However, some climate models suggest that if Proxima b has a thick atmosphere or a large ocean, heat could be distributed more evenly, allowing for a stable environment suitable for life. A new era of exploration. While telescopes like JWST continue scanning Proxima b from afar, future missions could bring us even closer. One of the most ambitious projects on the horizon is Breakthrough Starshot, an initiative that aims to send tiny, high-speed probes to the Alpha Centauri system, home to Proxima b. Using powerful laser beams on Earth, these miniature spacecraft, called starships, could be propelled to 20% the speed of light. If successful, they would reach Proxima b in just over 20 years, far faster than traditional spacecraft. These probes would capture high-resolution images and gather direct data about the planet's surface, atmosphere, and potential biosignatures. If signs of life, or even the potential for life, are found, it would revolutionize our understanding of the cosmos. Are we alone, or is life a common occurrence across the galaxy? Proxima b may be the first step in answering this age-old question. Beyond Proxima, the hunt for other Earths. While Proxima b has captivated scientists, it is just one of many promising candidates. With over 5,500 confirmed exoplanets and thousands more awaiting classification, the search for another Earth continues. NASA's upcoming missions, such as the Habitable Worlds Observatory and the Next Generation Extremely Large Telescope, ELT, will further refine our ability to detect exoplanets and analyze their atmospheres. These cutting-edge instruments could one day pinpoint a world with unmistakable signs of life, perhaps a blue planet with oceans, continents, and an atmosphere rich in oxygen. As we continue pushing the boundaries of exploration, one thing is certain: the discovery of extraterrestrial life, whether microscopic organisms or intelligent civilizations, is no longer a question of if, but when. The cosmic perspective. Every discovery we make, every exoplanet we find, and every signal we analyze reminds us of our place in the vastness of space. We are a young civilization, standing at the threshold of a new era, peering out into the cosmos with instruments more powerful than ever before. Proxima b, once just a distant speck in the night sky, now represents something much greater, the possibility of a second Earth. And if one exists, how many more might be out there? Perhaps, somewhere beyond the light years that separate us, another civilization is asking the very same questions, gazing up at their sky, searching for life, and wondering if they, too, are alone. And maybe, just maybe, we are on the verge of making first contact. Truly habitable, you might wonder how we can gather reliable information about a planet we haven't visited yet. That's where the James Webb Space Telescope comes into play. It is more than just a telescope, it's a research laboratory in space. With its advanced spectrographs, the JWST can study the light from distant planets, analyzing how it interacts with the atmosphere. By focusing on the specific wavelengths of light absorbed or emitted by a planet's atmosphere, scientists can measure air pressure, density, and even detect compounds crucial for life, such as water, organic carbon, and oxygen. Instead of passively waiting for evidence, the JWST actively searches for signs of life, effectively conducting a remote biopsy of these distant worlds. It's not simply an observer but a highly specialized lab and investigator rolled into one. This unique capability allows us to transform theories into verified scientific facts, expanding our understanding of what might exist beyond Earth. Just when you think we've uncovered all the layers of this cosmic mystery, the journey is only beginning. As we stand on the cusp of groundbreaking discoveries, the James Webb Space Telescope symbolizes a beacon of hope and progress. Its advanced instruments will probe the most intricate details of far-off worlds, revealing aspects of the universe that were once beyond our reach. The JWST's ability to analyze exoplanet atmospheres allows us to extend our search to the farthest corners of space. It gives us new insights into whether these planets could support life and how life might manifest in extreme environments. One exciting aspect of this research is the potential to detect biosignatures in exoplanet atmospheres. Biosignatures, such as specific atmospheric gases or unique chemical compositions, may indicate the presence of life. For example, detecting methane and oxygen together could point to biological processes, as these gases are commonly produced by life on Earth. The JWST's advanced spectrographs can detect these subtle signals, offering a new way to assess the possibility of life beyond our solar system. Furthermore, the search for exoplanets has led to the discovery of diverse planetary systems, each with its own unique characteristics. Some exoplanets are part of binary star systems, where two stars orbit each other, creating complex gravitational environments. Others orbit red dwarf stars, which are cooler and less luminous than our Sun but still capable of supporting habitable zones. This discovery of diverse planetary systems expands the potential locations where life might exist, even in environments we might not typically associate with habitability. Planets orbiting red dwarfs, which are far more common than stars like the Sun, could offer stable environments conducive to life, despite the star's lower brightness and variability. This growing diversity in exoplanet systems highlights that habitability may not be confined to the familiar parameters of our own solar system. One of the most exciting aspects of this research is the potential to uncover radically different forms of life that might not resemble what we recognize on Earth. Traditional models of life often focus on the need for water, carbon, and oxygen, but recent discoveries suggest that life might thrive in environments we never imagined possible. The search for biosignatures remains focused on familiar conditions that support life but is increasingly open to the possibility that life could emerge in entirely unexpected forms. Whether it's in the atmospheres of gas giants, under the icy surfaces of distant moons, or in extreme conditions we previously thought inhospitable, the hunt for life is expanding its horizons. Moreover, advancements in technology are revolutionizing our ability to detect even the smallest signs of life, or even advanced technology, on distant worlds. Instruments like the JWST enable us to identify the chemical signatures of life, whether biological or artificial, through gases produced by living organisms or pollutants left by intelligent civilizations. By studying the atmospheres of exoplanets in detail, we can determine whether these worlds exhibit signs of biological activity or even the presence of advanced civilizations. This heightened sensitivity to signs of life expands our definition of habitability, as we reconsider what it means for a world to be truly suitable for life. This search is not just a scientific endeavor, it carries deep philosophical implications as well. Discovering life elsewhere would challenge our Earth-centered view of the universe, reshaping our understanding of our place in the cosmos. Finding evidence of life or an advanced civilization would not only answer long-standing questions about our origins but could also suggest that life is a common and universal phenomenon, thriving throughout the cosmos. The broader societal impact of such discoveries would be immense, fueling imagination and spurring a new era of exploration. This shift would drive funding, inspire the next generation of scientists, and foster international collaboration as we pursue a shared cosmic goal. The questions we raise today, about the nature of life, our place in the universe, and the existence of intelligent civilizations, will shape the future direction of space exploration and technological development. As we continue to expand our reach into space, we must also prepare for new challenges that will arise as technology evolves. With each new breakthrough, we will develop more powerful tools to search for life in ways we can't yet fully conceive. The journey of discovery is ongoing, and each technological advancement brings us closer to understanding the universe. Looking ahead, the search for extraterrestrial life will not only be about finding life that resembles us or determining if life exists elsewhere, it will also be about exploring the many different possibilities the universe holds. As we push the limits of space exploration and technological progress, we're not just observing the cosmos, we're redefining our place within it. In doing so, we may soon realize that life in the universe is far more abundant and diverse than we ever thought possible, prompting us to rethink everything we know about existence. We are entering an age of cosmic discovery, where the dream of finding extraterrestrial life is no longer just a tale of science fiction but a tangible and exciting scientific pursuit. The James Webb Space Telescope, along with other advanced observatories, will continue to play a crucial role in this journey, helping us uncover new worlds, new biosignatures, and new insights into the mysteries of the universe. Each discovery brings us one step closer to answering humanity's most profound question. The search for extraterrestrial life is no longer just a speculative pursuit, it is rapidly becoming a rigorous scientific discipline, supported by cutting-edge technology and groundbreaking research. Each new discovery adds another piece to the cosmic puzzle, pushing the boundaries of what we know about the origins and prevalence of life. The expanding frontiers of astrobiology. Astrobiology, the study of life in the universe, has evolved beyond theory into a field driven by direct observation and experimentation. The James Webb Space Telescope, JWST, along with missions like the Perseverance rover on Mars and the upcoming Europa Clipper, is actively gathering data that could reveal whether life has ever existed beyond Earth. The next phase of exploration will likely focus on analyzing potential habitats more closely. Mars, for example, has already shown signs of past liquid water, and scientists continue searching for organic molecules that could indicate past microbial life. Meanwhile, icy moons like Europa, Jupiter, and Enceladus, Saturn, harbor vast subsurface oceans beneath their frozen crusts, environments that may be even more suitable for life than Mars. Future missions will aim to directly sample these alien oceans by penetrating their icy shells or analyzing the plumes of water vapor that occasionally erupt from their surfaces. If life exists in these dark, pressurized oceans, it may resemble Earth's deep-sea extremophiles, organisms that thrive in hydrothermal vents on the ocean floor, without sunlight. Beyond planets, the search for technosignatures. While the hunt for biosignatures focuses on natural signs of life, a parallel effort is underway to detect technosignatures, evidence of advanced civilizations beyond our own. Unlike biosignatures, which could result from microbial activity, technosignatures would indicate the presence of intelligent beings capable of altering their environment on a planetary or even stellar scale. Potential technosignatures include unusual atmospheric compositions, such as industrial pollutants that wouldn't naturally occur. Artificial megastructures, like Dyson spheres, hypothetical constructs that could surround a star to capture its energy. Radio or laser signals, possibly transmissions from alien civilizations attempting to communicate. Projects like SETI, Search for Extraterrestrial Intelligence, continue scanning the skies for such signals, though no confirmed discoveries have been made yet. However, recent advancements in artificial intelligence are improving our ability to sift through the vast amounts of data collected, increasing the chances of detecting patterns that might be artificial in origin. The implications of first contact. What if we actually found life, whether microbial or intelligent, on another world? The implications would be profound, reshaping our understanding of biology, technology, and even philosophy. A second genesis, discovering life elsewhere, even if microscopic, would suggest that life isn't unique to Earth but rather an inevitable outcome of the right conditions. Reassessing intelligence, If we encountered an advanced civilization, it could redefine our understanding of consciousness and intelligence. Would they think like us? Would they communicate in ways we could even comprehend? Ethical and cultural considerations. If we found a world teeming with life, should we explore it further or leave it untouched? Should we attempt to communicate with intelligent civilizations, knowing the risks of misunderstanding or even hostility? The future of exploration. As technology advances, the next generation of space missions will take us even closer to answering the question of whether we are alone. Future telescopes, such as LUVOIR, Large Ultraviolet Optical Infrared Surveyor, and HABEX, Habitable Exoplanet Observatory, are being designed with even greater sensitivity to detect exoplanets and analyze their atmospheres for biosignatures. Meanwhile, breakthroughs in propulsion technology, such as solar sails, nuclear fusion rockets, and even theoretical warp drives, could one day allow us to visit distant exoplanets instead of merely observing them. As humanity stands at the threshold of these discoveries, we are not just looking outward, we are redefining our own existence. Whether life is common or rare, biological or artificial, primitive or intelligent, the search itself forces us to confront who we are, where we come from, and what our future holds in the grand tapestry of the cosmos. The universe is vast, and its secrets are waiting. As we continue exploring, we may soon find that we were never truly alone to begin with.